मेनस इट्स शॉर्ट फॉर मेनस काट लूँगा एंड आज हम करेंगे mock interview का practice. And what you see in front of you is just me doing preparing the uh, preparing the what preparing the thumbnail, I guess. Yes. तो इसमें thumbnail बन रहा है. ठीक है. एक बार I'm just gonna ensure I'm just gonna close hide my browser real quick, and I'm just gonna check if my stream is working. Right, so we gotta see if our stream is okay. Is our stream okay, brother? Open widget, okay. So that's poor. That's just how the 100 midtown internet works, I guess. Just gonna reload this real quick. Testing. Okay. Do we have anything? Are we live? Uh, I think we're live. I think we are somehow live. Yo, testing, 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 testing. Cool. We're live. We're live. We're live. So this is stupid. This is live somehow, right? Gonna show my Steam browser, and this is where shit starts getting laggy, I guess, right? Yeah, I guess so. Okay, whatever, right? They say the connection is good now, but yeah, I doubt that. Anyways, cool. So let's put on a 20-minute timer real quick, and we'll unmute this. It started. Cool. So let's check this question. Design a stack that supports push pop top and retrieving the min element in constant time. Implement the min stack class, initializes the stack object, pushes the value, pops the top element of the stack, retrieves the min element of the stack in the stack, whatever. And you're expected to implement this in constant time, every function. Got it, cool. So the first question to the interviewer is what is going to be the max length of uh, the stack input? Is there a fixed length that I can expect in the stack, or is there like a max length? Then the second question to the interviewer would be what is the range of the numbers that are going to be pushed? Are we always going to push numbers? Can there ever be a push for an empty uh, value? Can I get like a push but the corresponding array element is empty? And I think that's about it. So I see the values can be negative, 2 to the power minus 31. Uh, there can be 3 into 10 to the power 4 calls that could be made. Cool. So my first approach in order to implement this would be to implement push and pop. I'm just going to maintain a uh, class variable called stack, and every time I get a push, it's going to be a list. So I'm just going to do a stack.append of that value. For pop, I'm just going to do stack.pop, and for top, I'm just going to do stack.-1, which is going to be the very last element in the stack, because stack is uh, last in, first out. So that's how I do it. Now, in order to get my min, what I will do is I will maintain another stack which I will call the min stack, and essentially I will check if the current element that I am pushing to the normal stack, if that is smaller than the current min stack stop, I will push that on the min stack. And if the min stack is empty, I just push some element so that it's non-empty. And when I'm popping something out, I just check if the element that I'm popping out is also the same element as my min stack stop. If the normal stack stop and the min stack stop match, then I pop both. Otherwise, I just pop the normal stack stop. And all of these would be constant time. So I can go ahead and implement it now. So I'm just going to do self.stack is an empty list. Self.mstack, which is going to be like a min stack, is also going to be an empty list. Now I'm going to simply do uh, self.stack.append of val, right? And I'll just complete all the other methods. So I know that we got to do self.stack.pop over here, and this is just going to be self dot which is going to return, right? Self.stack of -1. This is going to give us the top. Now to handle the main stack, I know I said that if self dot if not self.mstack, so if the self stack is uh, not empty, or okay, if the stack is uh, if not of this would mean that if the stack is empty, the not of empty is uh, true. So if I just do if stack, it means it's non-empty. If not of this, it means that the stack is empty for the first time. Or if val is less than self dot m stack stop, then I do self dot m stack dot append of val, right? In case of pop, I'll just say r is like some return value that we pop out. If r equals self dot m stacks top, I will say self dot m stack dot pop as well. And here I will just say return self dot m stack -1. So if I let's just quickly do some dry runs. Self.mstack is empty. These are both empty. So this is doing an append. If not of self.mstack, which is going to be if it's empty, then it's going to get in and append the first value. If it's non-empty, then it ignores this condition becomes false, but this condition goes and checks if the current value is smaller than the stack's min stack stop, which it is. So it'll append something here. R is going to be stack.pop fair. R equals m stack -1 fair. Okay, this should be okay. So if let's check some edge cases. What all edge cases can I get? I could get an edge case where the stack top is the value that is pushed to the stack is empty. Can that be can that be a case? So I know that this is always going to be int, so this can never be null. So that's okay. But if it is, sure, we can do something, I guess. If it is none, if val is none, we just gotta do return, because if nothing is being pushed, we don't gotta worry. Anything else does not take in any input, so that's okay. Could we get a condition where there is an instruction but an invalid corresponding element in the list? There is not any. So what happens if my stack is empty and I try to do a top, which is going to be a -1, but so if my stack is empty and I do like a -1, I should be okay, because like if I do an empty list and -1 of it, it should okay, interesting. So what happens if my stack is empty and then I try to uh, return something? Let's see, minimum element in the stack. So there could be a case where someone asks me to return something from the top, but the stack is already empty because I've popped everything out, right? So I can just say that if they haven't specified what to return in case there is nothing, but I'm just going to return none if self dot stack return this. Otherwise, I know that it's going to return a none. And similarly, if self.mstack, I'm just going to return this. Otherwise, it's going to return a none. I know it wants to return an integer, but we know, right? So what happens if I do like an empty list dot pop? It should throw an error, I guess, that you try to pop from an empty list, right? So that should be okay. And I think this in general assumes that we do not have empty list. So I'm just gonna run this. I think this is okay. And if I just submit this should be okay, I guess. Result type, okay. Push, pop, pop, push. Let's use this test case and see why this fails. Is it because I'm trying to handle these things? I think it could be because of these. That I tried to be over smart and like handle these things because uh, so it said list index is out of range. It should never happen because there is no. So if I do a dry run over here, I know that push will push in 0, then 1 will push in 1, 0 will push in 0. The min stack should not have anything but something like, okay, so if I just go here and I do, okay, if val is none, I could perhaps like do this. I can just do like print of self.stack self.mstack. So there's obviously something stupid that I'm doing, which is happening in this section, right? So I'm just going to check the inputs. So I know the min stack is perfect, right? So am I not calling the right variable here? So I do get min and I did a push, then I did a pop, right? So I did a pop, and if r equals mstack dot -1, so get min is this, which is gonna get 0, and when I did a pop, okay, so when I did a pop, print r self.stack self.mstack, so here's what I'm gonna see. So it's trying to basically do a, so r is gonna be 0, so r is essentially equal to 0, and the issue is that because 1 is not something, oh my god, it should have been, I think, this, and then it works, I believe. That's an edge case because I did not think of the case where something has been pushed onto min stack and then the stack top, I forgot that there could be duplicates, and having duplicates kind of is bad for us. My bad, output limit, because I had a print statement in there. Anyways, that's okay. Cool, so we have solved this, but let's see how long it took us. It took us like 17 minutes. Let's restart this. Cool, so 17 minutes is meh, not as good as we wanted it to be, but whatever, right? So let's try to do a new question, I guess. It's gonna be called rotate function. So first of all, I'm gonna go to algorithm notes is good, but I also wanna like docs.google, I guess. Screw this, I need to be in sheets, and I'm just gonna like do some analysis of my mistakes here. Mistake, while maintaining two stacks where duplicates can be pushed, I assumed that both stack tops would Okay, duplicates can be pushed. I tried to pop by checking if both stack tops are same element. Although this works, but in reality, when duplicate values are pushed to the main stack, okay, when values are pushed to the main stack, I should have checked val less than equals m stack minus 1 instead of val less than i.e. don't just check for min value at the top of the, okay, don't just check for strictly decreasing values compared to min stack top. Check LTE less than or equal to. Cool. Cool. So this was at least big of one, so I can just get rid of this. Right. So let's just start this now. Cool. So you're given an integer array nums of length a. We assume uh, arr to be an object obtained by rotating nums by k positions clockwise. We define rotation function f on nums as following. So 0 times the array 0th element, 1 times the array first element, and so on and so forth, and return the maximum value of f1 f0 to fn minus 1. The test cases are generated so that the answer fits in a 32-bit long integer. Cool. So the way I'd like to do this is, first the questions to the queue to interviewer. One is, what is going to be the max length of the nums array, uh, max len nums, and next is, are values unique, then range of values. This is another one to ask. So max length of the numbers, 10 to the power 5. So I know this is like 10 to the power 5. Other values unique, let's see, obtained, we're defined something, return the maximum value of this. Okay. Okay. So I'm assuming no, because there's no explicit mention that values are unique, could be non-unique, right? And then range of values. So it's gonna be minus 100 to plus 100, so it's just this much. And the maximum length is 10 to the power 5, so that means that obviously by pigeonhole principle, there's something's gonna be like repeated. And the array's kth item, array k is to be an array obtained by rotating nums by k positions clockwise. So cool. Rotation on that number is, if you have n objects, n minus n objects, so it's essentially 0 and a 4. So that ith element, So you are given an output 26. Output is 26. So you do F1, 2, 3. So you are essentially given uh, all Fs, right? And then you're essentially asked to do a simple uh, rotation, I guess, right? So a single algorithm that I can think of is, I know that there are going to be like 100 n numbers in there, right? I know there are going to be like 100 numbers in there. Sorry, there's going to be like 10 to the power 5 numbers in there, minus 100, 200. So one simple thing that I can do is, I know that I can do like an iteration of n cross n. So like it will be like an n squared nested loop, and inside the nested loop I can just go through every element and do a sum for that particular iteration, and I can keep a record of like some max out there, and that will be like a n squared time complexity function. So I can like perhaps code it out. It will be like n squared, and the like the space complexity will be like big of one, because I just need to store the max. The space complexity will be just uh, the space complexity will be just one, so I can just do that. So max a is gonna be mm, uh, just something like minus 1e6 or something, or maybe 7, something like super bad, super small. And then what I can do is for I in range len nums, I guess, cool. For j in range len nums again, because I need to go through all of them, and I can just do like temp equals say something 0, and I can simply do uh, right. So, and I know that for every uh, rotation, so like for this one I did 6 first, and then 2 first, then 3 first, and so on and so forth. Right, that's how we do it. And I know that this is going to be like a multiplication, and I'm pretty sure that within this there are going to be some repetitions. Like there's going to be 3 and 3, there's like 1 and 4 or something, I guess, right? So I know that there could be some repetitions somewhere which I can like reuse in some case some shape. So like for example, like 3 into 2, right? And 2 into 3, these are like repetitions. Like I know if the index and if that pair exists, I could perhaps cache it later on. Like that's what I'm thinking. Like 2 4, I'm pretty sure there should be some like 4 2 or something somewhere, right? So I'm thinking that could be like a way to do this. Way it is faster maybe, but for now I'm just gonna do this like uh, temp plus equals j times nums of I, nums of j, sorry, j times nums of j, right? And I'm just gonna be like we know for a fact that this in every iteration gonna remain the same. So j is gonna always go from 0 to like length of nums minus 1, but the index of this, it's gonna change, right? It's gonna always change. So it's first it was 3, it started from 4 3 to 6, but next is gonna start with 6 4 3 2, right? So it's this part is gonna change a little bit. So I can say that it's gonna be j, right, plus some number I, right? And I can then say that it's gonna be j plus I percentage of length of nums maybe. So let's see, if it's 0, then it's 0 plus 0 percentage nums, which is like whatever, and 0 1 2 3. So this is what it does. Now when it goes to iteration 1, it's gonna be like 0 plus 1 is gonna be 1 percentage uh, 1 percentage 4, right? So it's going to be like 1 percentage 4. It's going to be 1 again, but we don't want to go to 1. We want to actually go to we want to actually go to 0, 1, 2, 3. We want to go to 3 rather than 1. So I can perhaps say this part, this little buddy is len nums minus I, for example. Maybe I could do this, right? Um, I'm thinking this doesn't make sense, to be honest, but after my first iteration, I know I want to uh, rotate this in some sort of sense. So if j is 0, uh, my offset should essentially be 0, 1, 2, 3. It should be 3, right? So if it should be 3, then so I can say len nums minus len nums plus 1, I guess. So I know it should be like length of this. So suppose the length of this is 4, and I want this to be at 3, index 3, and starting with 3. I think it should be just like, oh, it could just be I into length of this, right? So if I do this factor, it's like gonna be 0 plus 4 into 0, right? But when I do the next iteration, it's gonna be 0 plus 4 into 1, which is gonna be 4, but I need a minus 1 here, so I can just do like so I could just do like length nums minus 1. So I'm going to be like 3, for example. This one also would be like 3, for example, and like percentage 4. So this again starts with 4, right? So if I just do like 3 percentage 4, it's just gonna be like 3 again. What if I do 4 percentage 4? It's gonna be 0. But what if I do 0 plus 3 into 2, for example? So it's gonna be 6. And what is 6 percentage 4? It's gonna be 2, so it's just gonna be 0. It was here first, then it came to 2, 3, and then it came to 4. So if I do 3 and percentage 4, so if I just do like 9 percentage 4, it just be 1, so it just moves 1 level back, I guess. So this equation should hold. And what if I do like 0, 1, 2, 3? What if I do 3? So it should be like 3 percentage. It should actually be 3 plus I believe it should be like 3 plus 3 into 3, which is 12. And what is 12 percentage of 4, which is 0? So if I go to 3, it should be coming at 0. Like the 0th element should be 4, which is this. So 3 comes to 4, which is exactly what we wanted, right? And I'm gonna say that, right, maxa equals maxa temp, and I'll just say return of maxa. So if I run this, this should give me whatever is my maximum value, right? So this is going to be big O of n squared plus so this is going to be, my time complexity is going to be n squared because I'm going through this and also going through this. And then I know that my space complexity is constant because I'm just using like one variable to store the maximum value. Now the question is there a way I can say that I can reduce the time complexity, for example? Like I know that perhaps what if I can do like n log n? Can I do n log n? Some valid ways to make this n log n would be like divide and conquer. That's one way to make it n log n. I could perhaps do a divide of left and the right. Can I independently carry out the operations in here? Not really. I would need that particular index to make sense of how to rotate these. One thing that I'm thinking is that for every pair of like j and this element, I could store it in a hash map that hey, I have seen this pair and I have see the multiplication is commutative, so I can say that I've seen this pair and I've seen the opposite of this pair as well. So if I see that in the hash map, if I see j and that particular number in the hash map, instead of doing that computation, I could just say that hey, you know what, I'm just gonna get it back from the hash map. But that doesn't make any sense because I'm just avoiding a multiplication and just copying a product. Like I'm just like reading a value, I guess. Uh, Thinking if there is a way to do this faster, right? If can I do this in linear time? I wonder. If I want to do this in linear time, I can see that instead of doing it like this, right? I can also uh, okay. So we know that the answer is going to be fit into a 32-bit integer. Let's just see if the topics that this is again I under. So I know this comes under dynamic programming, so I can perhaps use this to my advantage somehow, right? So if it's being used under dynamic programming, then say that I have, um, what if I create like a 1D array? Can I create like a 1D array with values in some way? Okay, so I'm just gonna spitball a bit here. If I can do this in like some a bit faster time, in some way. If I were to do this in 2D DP, then it would perhaps take the same amount of time and then beats the purpose. I don't want to do this in 2D. I want to do this in like perhaps 1D, right? So if I were to look at the path that this is taking, right? Like I know that in these the biggest term is gonna be 18 and 12, for example. The first term is always 0. The last term 18 and 12 is the bigger one. Then I'm checking perhaps like which is the bigger term in all of these. Okay, so how about this? Like, how about this? Suppose I say that I have a DP which contains F0, F1, F2, F3. Suppose it contains till F2 all the most perfect values, and in this case we can see that till F2 the best values are essentially something else, I guess. 3, if I were to ignore here, F3 is just a rotation, I guess. One way I'm thinking I could do this is just like memorize the I and J somewhere. Instead of doing the product, I can be like, hey, I've produced the product before. So I could perhaps. Okay, let's see what information do we have here, right? Like if you want to do this with dynamic programming, for example, can we bring this to linear time complexity? Can we just do this in n? So if I do this, want to do this in n, I have gone through 4, 3, 2, and 6 once. And if I've gone through 4, 3, and 2, 6 once, I know that would it be fair to say that if I were to sort these somehow, right? If I were to sort these somehow and sort these from their ascending to descending values, right? Okay, but sorting gets rid of the order and we do not want to get rid of the order. What we do want to do is somehow get an order where the largest numbers are grouped together in a way, right? Like 4 and 6 are too far apart, but if I were to like, the problem is if I were to sort them, that would have been the best answer because I could have sort them in like n log n and then give my solution in just a simple way, which I can't do. So I can't sort it. But let's say I had a sorted array instead of this, right? I knew exactly what is going to be the uh, order, what is going to be the magnitude. Say I was sorting this array in n log n, and then inside the array, suppose I also like in the sorted array, I also preserved the index of that number in its original array. Could I then assign some sort of priority to it, that hey, you know what, you came from this particular position and then you want to go to you are the most sorted element, but can I assign you a number? No, I can't, right? So let's see, for 4623, can I assign it anything? I can, essentially, right? Okay, one thing is clear, that the biggest numbers I'd want to give it the biggest values, right? So I say I keep a, is there some sort of path that I can traverse to get to this? Like I have 4, 3, 2, and 6. Like forget dynamic programming, could be perhaps dynamic programming able, but let's say 2D, if I were to do dynamic programming, let's just give into that thought once. Instead of n squared, if we could do perhaps like something lower, but that's fine. If there's a way to think of this in dynamic programming terms, I know that I want a combination of all zeros and all other elements. So like I could have like a 2D array, for example. Like I could have a 2D array of say 4, 3, 2, and 6, and then like a 1D array of 0, 1, 2, and 3. And I know that everything with 0 is just gonna be 0, right? So this is one thing that I know. Now for 1, can I use my previous computation in some way? Like for 1, I know that it's gonna be 4 into 1 or 3 into 2, right? So these are gonna be diagonals, right? So it's gonna be like 4 into 1. So I could perhaps say like this is 12. Oh, sorry, it's gonna be 3, it's gonna be 2, it's gonna be 6. I know this is gonna be like 8, 6, 4, 12. And I know this is gonna be like 12, then 9, then 6, then 18. So I know that this is how it's gonna turn out, my 2D array. And in general, the way of combining these two, can I perhaps say that, well, let's see the optimal path here, right? Like optimal path is 12, 12, 2. So it's 12, 12, 2, and 0. So it's 12, this, and this. So it's interesting because it's just one of these diagonals, right? So I say that I have a way to populate these, right? I have these, and I know that I start from this. Can I perhaps look back on this? Like I'm like, okay, I have this, 3, and it's just this diagonal. This is one diagonal, is another answer. this diagonal is another answer, this diagonal is another answer, and so on. So all these diagonals are a particular question's answer. If I want to do it in n, then it means that I'm kind of traversing this matrix in some sort of path, I guess, which I can't. But can I reuse the computations in some form of shape? Uh, let's just see. For example, two and so let's see two and two. For example, right? I know what one and two is. I know what zero and two is. Can I compute two and two in a way that I can reuse older computation? I can't, I guess. Hmm. Hmm. ठीक है, ठीक है. ठीक है. We know that it's just a multiplication. Really? So I'm just gonna try to do my hash map logic. Mult hash is what I'll call it. Cool. And I'm just gonna say that key 1 is equal to j comma whatever is inside of this. Key 2 equals j, I guess. J, I guess. If key 1 in mult hash, oopsie, if key 1 in mult hash ठीक है और and this is mult hash of key 2 and yep, this is how it will be. Oh, the sigma, bro. What the sigma, bro? So I'm just gonna see if okay, this did obviously fail because I kind of saw the issue that yeah, I'm just gonna get rid of this, run this. Dynamic programming, I have to still figure out how to do this. I know this is gonna fail for large inputs, but let's just see by how magnificently it fails. Oh my god, this is just too slow. Pretty sure it's gonna be like, hey, time limit exceeded. Cool. So time limit exceeded for these, and this is like pretty huge. It's just fifth test case too. So I know that n squared is definitely not gonna work for this. Gonna get rid of this, but run this and it's gonna run into an issue. Now the question is, I'm wondering if there's some sort of like bit manipulation or some shit that's happening here. Okay, so let's see if I could perhaps, if I had answers from 1, 2, 3, F0, F1, F2, what happens if I add, right? If I had nums, right? If I had nums, it would have been 0, 1, 1, 3, and 2, 2. And then F1 would have been something quite different, right? So, thinking, I'm thinking how to handle this motherfucker. It's a good question, honestly. Right, so let's see what is it that we are missing in this question. N square is too bad, firstly, that we know. What is the form of this question, right? Like, we know that you're expected to combine every element with every other element and then take the max. But there's something obvious that could be perhaps done here. What does that mean? Like, how do you know that a number is maximum when the maximum index and the maximum values are continuously multiplied? The most optimal one would have been where 6 was multiplied by 3, 4 was multiplied by 2, and we kept going. But the problem is the array is not sorted in that way. That's not the order that you get once you sort. So that's kind of bad, right? So, what if I had a way? What if I had a way of directly sorting the array first or reordering the array such that the largest element are together, maybe? Right? For example, 4, 6, and 4, for example. 4, 6, 2, 3, for example. This is like a pretty interesting combination. How do you get this? No. If I were to say that, okay, I have F2, can I get F3 somehow from F2? If I had only one element in the array, which is like, say, 4, right? Or if I just had 3, 2, or 6, right? Just these three individual elements in my array, then the answer would have been whatever it is. Now, what if I had one extra element in the array, right? Can I use the previous elements computation somehow? I can say that, okay, that I have 4 and I have 2, for example, in separate arrays. Now, if I combine them, the way to combine them would need 4 multiplying 0 and 2 multiplying 1. Thinking, 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 thinking. Good question, this is. How much time do I have again? Oh, it's done. Cool. So let's just try again. So we know we crossed 20 minutes already. This is a pretty tough question. Rotate function, right? Okay. Dynamic programming to rotate this. This seems like a DP problem. We know K positions clockwise, right? Can the clockwise rotation be somehow done faster, I wonder? No. So it does feel like there is no way to do this in smaller time, but I know there is, because otherwise this question wouldn't exist. And if there is a way to do this in a less than n squared time complexity, what are we missing? So here's the reason why I feel so far. Here's the reason why I'm stuck on the fact that it needs to be n square. And the reasoning in my mind is that the reasoning in my mind is that every rotation is going to take me um, every rotation is going to take me yeah, every rotation is gonna take me. I need k rotations, right? So I'm assuming by default that my k is equal to n, which I think could be like a trap in general, like 0 to n. Right. Maybe the array does not have to rotate k times, n times, k equals n times. Maybe that can be done in than that, less than the time. Can it be proved though? So rotated array k times this much. So if I were to look at this, right? What is rotated array of k minus 1, right? It's just array k minus 1 times that. So if you think about it, I have an array. I have a max k for that array. So 1 in 1 into array k of 1 is the same as is the same element that will be found at k minus 1 is anti-clockwise, or k plus 1 is going to be clockwise, right? And that implies that 1 into 3 is essentially just 2 into 3 in the k plus 1th array. Can I express it in the terms of my previous array in some way? I can say decompose 2 into like 1 plus 1 into array k. So I know I'm just doing like adding plus 1 of these, I guess. So let's try to see, okay? Let's try to see if k is gonna be something like 0 4 plus 1 3 plus say 2 2 plus say 3 6, for example. What would k plus 1 be, right? It's gonna be a array that is like this. Now 4, we just gotta be like 1 plus 0 into 4, right? Plus 1 plus 1 into 3 plus 2 plus 1 into 2 plus this is going to be 3 plus 1 percentage 4 into 6, I guess, right? Now let's see, this part is essentially, I can say that k plus 1, it can be decomposed into uh, ARR of k, which is like whatever was at the, okay, f of k plus f of k uh, plus 4, for example. Then f of k1, I'll call this, for example, for now, k2, k at 0th position, k at 1st position, right? Plus 3. So it's like basically you're doing a plus here. Can I claim that the next step is also going to be the same? Right? Can I claim that the next step is also going to be the same? Do you want me? Yeah. So it's just essentially rewriting it, and I just know that the previous one के बाद तुमको बस एक मिल रहा है, तो rotation, every time you do a rotation, you are simply adding 1 to the value, right? You're just adding 1 to the value. So जो पहले का था solution, right, it's just 0 into this, 1 into 3, this is like 2 into 2, and this is like 3 into 6, right? So if I go into this, I just know that's like 4 plus 3. Okay, sorry, it's like 0 plus 3 plus 4 plus 12, right? Sorry, 18, right? This is what my answer was. Now, I know one thing for sure, that this answer is supposed some A. This answer can just be mentioned as k plus 1 is A plus 4 plus 3 plus 2, right? Right, so it's just like A plus 3 plus 2 minus, say, 18, because that's the term that's becoming 0 now. Right, so that's the only difference that I get, I guess, because it's essentially doing 3 plus 1. Right, so suppose this is like my B. Now what is k plus 2 would basically be B plus 3 plus 2 plus okay, it's just gonna be like 6 plus 3 plus 2 minus like some 12, I guess. Right, can I say that? So let's say 3 plus 4 is say 3 plus 4 is 7 plus 18 is 7 plus 18 is 25. Cool, suppose this is like 25. Now I know that this is going to be like 25 plus 5, 34, 34 minus 18, so would essentially be 16, right? So B equals like 16, I guess. And I know this would basically be 9 to 11. 11 minus 12 is minus 1 plus 16 is 15. Hold on, this doesn't make sense. So k plus 2, right, this dude right here should have been the previous one, which is 2. Oh, sorry, it should have been now 4 plus 4 plus it should have been like 6 plus 4 plus 6 plus 4 plus 3 minus something, right? So it's not 15, so it's essentially like 10 plus 3, 13, 13 plus 13 is 29 minus 6, because 2 into 3, so 2 into 3, which is 6, which is like 29 minus 6 equals 23, I guess. So this part, which is essentially 3 into something, right? So every time you're minusing something from here, you're minusing that element, you're removing that element minus into something times 3, because every time it becomes like the last element, everything becomes like the last element, you're just like removing minus 3. Minus 3 is just a last element, like n minus 1 into that element, right? So this part essentially is just a summation, right? So for example, if I have f0, right, suppose I have like f0, so more formally, if I have f1, it's gonna be like f of 0 uh, plus sum of everything, uh, sum of everything till f0 was 4 on 4, so 4 3 2, so 4 plus 3 plus 2, and minus n minus 1 into 6. This is essentially my recurrence, I guess. This part right here, instead of 6, I wanna like do like a better way of representing this, because f2 is just gonna be this, right? So sum of ARR 0 n minus 1. So this is how I would say, this is how my minus n minus 1. So this is how I would say f1 is, right? Now f2 would essentially be just this instead of 1, right? Instead of this 1, oh sorry, f2, this is like f2 for me. So instead of 1, I would do nums of this, say like a whatever is so no, it's gonna be a sum, right? It's gonna be a sum of everything, right? So suppose I calculate this sum of all terms as S all is uh, just sum of nums. This is gonna be like big O of n, and this is fine, right? SO, right? So S all minus of, I know I wanna do this term. I wanna do this term, right? And in this case, I just wanna do like sum of S all, but instead of n minus 1 into this, I was doing n minus 2, but I also want to take this one out, right? So essentially this is my equation, right? So if I were to like make this a little better, I guess, this is how I would say my sum is, like 3 is f of 2, s all of 3, for example, right? So now let's just give it a try, right? So my sum all is, if I do like a sum of everything here, it's gonna be like a sum of, it's gonna be like, so sum of it's gonna be 15, right? And let's just say f0 is gonna be something, right? F0 is also gonna be like, what is f0 gonna be, right? F0 is gonna be some base plus 15. So say that I calculate my f0 for the very first time. That's going to be like my base case, for example, right? So say my base case is 25. Now this is going to be like 25 plus 15 minus, uh, my n is 4, right? So it's, my n is 4 here. So 4 into, what is nums of n minus 1? It's 16. So 16. So this is essentially something. Oh, sorry, 6. It's gonna be 6. My bad, not 16. It's gonna be like 6. So which is essentially 16, right? Now this is gonna be again 16 plus 15 plus minus 4 into, what is n minus 2? N minus 2 is 2 this time, which is 2, which is going to be simply 20, 23, which makes sense, right? So this is good. Like this is like linear because S all is computed once in big O of n. This n into this is like computed once. So I'm just going from 1 to n, and I'm just calculating these. So I know I get this now. So let's try to answer this in our really good way. Okay, so cool. So this is essentially what I think is gonna be. So I'm just gonna be like S all equals sum of nums, right? Now the question is, can I perhaps also do this in some shape or form? Like, can I express this one also in terms of my something? Like, okay, let's just call S all as this. F0, I'm gonna say is, F0 is gonna be like, sum, of course, it's gonna be sum of I into nums of I for I in range of length of n, right? So I'm just gonna be like L equals length of n nums, and this is just going to be L, just so that we don't waste time in anything. Maxa is again minus 1 e7. Why not, right? And for I in range of 1, say like a, oh, actually this is what we can do, right? Maxa is just f7 for now, 1 to L, right? And I know that we need to go to n minus 1, so we know that this is essentially equal to, and do we need something before this? I don't think we do, right? So I can just say prev instead of this, so I can just say previous. So I can say cur is equal to prev plus s all minus n times whatever is nums of L minus of I. So if my L is 1, this is just gonna be like this. So nums of L minus 1 should point to 6, which should be sensible here. And maxa equals max of cur maxa, and pre equals cur, and we gotta return maxa, right? This gotta be like the n solution. Oh, sorry, L. This is how it should have been, my bad. So this worked, right? And we were able to decompose this. So the way to do this was essentially just expressing this in terms of something beyond this, which is pretty good, I guess. Hopefully this works. So this beat like 29% of these. This is like big O of n. So I would say that the time compressed TC is big O of n, or like n is like the length of numbers. I'm just gonna like call this n, call this n, call this n, and call this n. So this makes complete sense now. I would just say this was big O. Okay, TC was big O of n square, and this we didn't need. SC was big O of 1. If I take this here now, big O of n, space complexity is also big O of 1, so this is like faster, better, and cleaner. This was essentially the key, like simplifying this was essentially the solution, and I think we did pretty well. I think we did pretty well in this one, and this is actually a pretty important function because this is like let's see how long it took me. Okay, it did took me too long, right? I don't know how long that took me, but it took me considerable amount of time. But let's see. So you go here, rotate function, mistakes. I didn't do any mistakes. Where did I get stuck? Optimal approach was with DP. So okay, cool. So optimal approach was with DP. I got stuck because I could not figure out the overlapping sub problem. So this is good. This is pretty good. This is pretty good, and I am happy that we were able to solve this. It's just that we gotta do it faster. What else? So overlapping sub problem is something that I could not do. I tried to do it in 2D. Okay, so mistakes. One, I spent too much time trying to formulate this as a 2D DP first, which makes no sense because this is already a ON square root force solvable question. DP had to be 1D, right? This had to be 1D. Now, optimal approach with DP, I got stuck because I could not figure out the overlapping sub problem. Why could I not figure out the overlapping sub problem? Because I was not focused on okay. Let's just rewind and say because I was not even trying to formulate the relationship between n and n minus 1. So I should have essentially tried to do the relation between n and n minus 1, but I just did not. I just was like, okay, I grew confident that I. So here is the thing. Here is the thing. Um, I kind of get it that it can be solved in just linear time. Right? This can be solved in linear time. And in general, okay, I get it now. I get it now. So this is a pretty decent problem. N and n plus 1, let's just say. So between n and n plus 1, I just did not try to formulate this. I did a base case and then I just decided, hey, you know what? I'll try to do the rest in some other way. But I was able to figure it out. And I make any mistakes in the code when I was trying to solve this? L was the mistake because I tried to do L here, which kind of was a mistake. But make it sense that that was like a mistake that I should not have done. But that's okay. We were able to figure this out at least. Right, so and I'm just like solve notes. I'm just gonna paste this in solve notes. No. Right, so this is what I'll put in solve notes. Okay. I'd ideally want to like insert format wrapping. What happens if I do warp? No. What happens if I do clip? Clip is better because like if I want I can just expand this. Review again, I guess. So this I gotta review this again. But let's try to see where I could have sped up my approach. One is this, like of course I simplified this and I got to make it work, but why is it that it took me so long to solve this? Like it should not have taken more than 20 minutes, but it did take me more than 20 minutes, which is kind of annoying, which is kind of super annoying. Which is kind of super annoying. Oh my god, that's so stupid. Sorry. So, let's see. What could I have done differently? So, equation was straightforward. I was able to do like an equation right away. I was able to do, okay, I spent some time in doing verification of my results. Like I tried to do mental addition and so on. And that was like one problematic thing I guess I did. But this is a pretty decent question. Right? I think we are able to get this pretty cleverly. Okay, let's move on. Maybe I will write one more concluding note. I got stuck because I could not figure out the overlapping sub problem because I was not even trying to formulate the relationship. Because, okay, I wasted too much time thinking that, okay, there's no way I can do this. If it's an equation, okay. If an equation of sorts, equation is given, just use it. Cool, that's what I'll say. Cool, so use it is too vague, I guess. Use it to figure out overlapping sub problem. Cool. So overlapping sub problem. So could I have looked at this problem and then just went like, oh, there's an overlapping sub problem that I have for this? Could I have seen this and just like, whoa, I need an overlapping sub problem for this? The moment I see something happening in n square, something that is obviously solvable in n square, I know that the only next solutions are gonna be either a divide and conquer or some n log n or n. If I know that it's solvable in n square and I need to do it in n, then I know that it has to be like either dynamic programming, some sort of hash map, or some sort of like divide and conquer thing, right? But let's see. Cool. Anyways, this is pretty decent. We gotta close this. We'll move on to our next question now. Let's see. Let's see. Okay, different pairs in an array. Cool. Oh, have I already solved this? Okay, hold on. Boom, I got rid of it. I have solved this, it seems, but I just want to like refresh my memory, see if I can solve it again if I needed to. Array of integer. Okay, let's start the timer first. Given an array of integers, I'm gonna put a timer externally as well. So given an array of integer nums and integer k, return the number of unique k def pairs in the array. The k def pairs is an integer nums I nums j where the following are true. 0 and I is not equal to j, so I cannot be equal to j, and the difference between nums I and nums j has to be equal